Today we're talking about 10.4. Happy Friday, everyone. Our first full week at home. 10.4. So remember we talked about central angles 2 days ago? So for a central angle, let's just remember, as a reminder, remember a central angle is an angle where the vertex is located on the center. And the measure of the central angle equals the measure of the arc. So today we're going to talk about another type of angle that involves circles. So the first one was central angle. This next one is called an inscribed angle. So this is very similar to, remember, like a triangle inscribed in a circle. That's the same type of idea. So inscribed angle. An inscribed angle, the vertex is on the circle. And the sides of the angle are chords. They could be chords, they could be tangents, they could actually be, they could be secants too, actually. Another definition, intercepted arc. Intercepted arc. An intercepted arc consists of endpoints, that lie on the sides of the inscribed angle. The verb that goes with this is subtends. I don't know how often you're going to hear that word, but this is the verb form of this process happening. So I'll give you an example of how these all work out. So let's sketch this out. We have a circle. We'll call this A, B, C. So angle ABC is an inscribed angle because the vertex is located on the circle. It's literally on the pencil mark that you created to make that circle, it's on there. So angle ABC intercepts arc AC. So AC, arc AC is an intercepted arc. So it's basically like the arc is in the mouth of the angle. I don't know how you want to look at it, but because the angle hits the circle there and hits the circle there. And so it's all the points in between. That's the intercepted arc. And then you could say that a arc AC subtends angle ABC. So I don't know how, we're not going to really use that word that often. Okay, there are different types of inscribed angles actually, and they all have the same relationship with the arc. So here are examples. One, two, so one example is what we had, two chords like this. Another example would be a chord and it could be like a tangent like that. Another one would be if we had, a diameter technically is a chord, so I guess this would be two chords also, but you could have something like that going through the center. All right. The relationship for inscribed angle, inscribed angle is half the intercepted arc. So if, let's say this angle is 30 degrees, that means the arc is 60 degrees. So remember for central angle, it was equal to, like, this angle would be 60 degrees if that was a central angle. But this angle, the vertex is going further away. So that angle, even though it's intercepting the same arc, it has to pull back farther and go further away. And so that angle actually becomes smaller. All right, so we'll do an example. Question so far. Draw three chords. P, S, R, U. So angle SRP, oh my gosh, angle SRP is equal to 27 degrees, and arc, measure of arc PU is 118 degrees. So I want you to find angle PRU and find the measure of arc SP. Okay, so angle PRU, angle PRU. Okay, so anytime you have these angles in the circle, you're always looking for what is the intercepted arc? The intercepted arc for this angle is this arc right there. And we know that is 118. The angle is half the arc, so angle PRU is equal to 59. Next, we're looking at angle SRP is 27. Again, you're always looking at the arc. the intercepted arc for that angle, which is that arc there. And that's what we're trying to find. It's half the arc, so we're going to double this. So this is 54. Questions on that? Okay, probably thinking that was too easy because it was. All right. Okay, so another example. We have okay, so A, B, C, D. Angle ABD is equal to 40 degrees. What is angle A, measure of angle ACD? Like this problem does come up on a test and a lot of people get stumped on this. Are you guys ready? Ready, okay. Angle ABD is 40, so this angle here is 40. Remember, every time you are looking at angles in a circle, you're always looking at the intercepted arc. The intercepted arc is this one here. The intercepted arc should be what? It's half, the angle is half the arc. So yes, thank you, Neela. This is 80. Angle ACD. Angle ACD here. What is the arc that it intercepts? Isn't it the same arc? So that means angle ACD is also 40. So this is actually a theorem. So let's write this theorem down. Theorem. This is called inscribed angles of a circle. Theorem. These names are awesome. Okay, so we have a circle and we have angles like this. Oops. It says if two inscribed angles intercept the same arc, then they're congruent. Then the angles are congruent. That makes sense. I mean, so that means this angle is going to be congruent to this angle. That also means this angle is going to be congruent to this angle. What do we know about those triangles? Ooh, interesting. These triangles are similar triangles. Yes, thank you, Kira. They're similar triangles because they have angle, angle. All right, let me give you an example. This. Okay. E, D, N, G, F. So measure of arc DG is 100. angle EDF equals 2x plus 3, angle EGF equals 75 minus 2x. Find angle D and E. Oh, the answers to 10.3 are not online. Did you check recently? This problem, we see EDF, this angle, is congruent to this angle here because they both intercept this arc here. So they're congruent. So 2x plus 3 equals 75 minus 2x. You should have that equation. You also should see that arc DG here is 100, which makes which angle, so you always look at the arc, which angle intercepts that arc, and that would be this one. So this is 50. You should get 39 here. After you plug in everything, x equals 18, by the way. And then you should get 91 for your answer. Questions on that one? Okay, 2 more theorems. The theorem, this is called the inscribed right triangle theorem. So this theorem says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter. Converse is true. A lot of people get stuck on this too. They'll see this picture and be like, I don't know what to do here. I don't know inner information, but then you actually do. So here's a diameter. If you have an angle that's inscribed like that, this is a right triangle. How do we know that? Well, this is an inscribed angle. Isn't the intercepted arc, isn't it this whole thing here? Intercepted arc is all the way around that way, which is a semicircle because this is a diameter here. So that makes this a right angle. So you can also think an angle inscribed in a semicircle is a right angle. The last theorem, inscribed quadrilateral theorem. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So this is if and only if. So if the opposite angles are supplementary, then the quadrilateral can be inscribed in a circle. So what does that mean? This means that we have a circle and a quadrilateral is inscribed here. This could only happen if the opposite angles are supplementary. So this angle is supplementary to this angle. And then the other two angles also. This makes sense. Doesn't that make sense? Because this angle's intercepted arc is this whole arc right there. That's for this angle. For this angle, the intercepted arc is this. So we cover the whole circle. And we know inscribed angles are half the arc. So together they should be 180. Because if it's covering the whole, if the arcs are 360, the angles are half of that. Together they add up to 180, that means. So you could also say opposite angles in inscribed quadrilateral are supplementary. So if you see a quadrilateral in a circle, that means it fulfills this. The angles add up to 180. Okay, let's do 2 examples and then we'll be done. Okay, so J, K, G, H. Say angle K is 10x minus 69. Angle J is 6x plus 20. Angle G equals 3x plus 25. So find all the angles. So this is a quadrilateral inscribed in a circle. So that means we know that the angles are supplementary. The opposite angles are supplementary. So that means angle J and angle G are supplementary. Angle K and angle H, we don't know angle H, so we're going to use these 2 expressions to set this up. So angle J plus angle G equals 180. You should get x equal to 15. And then we'll plug it all in. Angle K ends up being 81. Angle J ends up being 110. Angle G is 70. Angle H, well, we know they have to be supplementary, or we know they all add up to 360, however way you want to figure that out. So this is 99. Questions on that? Okay, our last example. This circle O. U, S R. Arc RS is 50 degrees. Angle RTU is 3 times 14x minus 12. Find angle RUS and find x. Let's start with arc RS. This is 50 degrees. That arc is the intercepted arc for which angle is this angle here, which is what we're asking for, angle RUS. So half the arc, so that's 25. For x, this is the angle that we know is 3 times 14 minus 12. That angle, if you look at the endpoints of that angle right there where it hits the circle, that's the endpoints of the diameter. So that tells you that angle T is a right angle. It also tells you like this semicircle is the intercepted arc, or you could think of it as an angle inscribed in a semicircle, however way you want to think about it. But angle T, so 3 times 14x minus 12 equals 90. So x should be 3. Questions from that? Okay, then this is all for today. I will see you guys Monday. Have a good weekend. I will look into Schoology and then you can start turning in your homework. I will be setting the deadline for Friday, next Friday, not today, next Friday for your homework. It needs to be completed and corrected. Yes, you're supposed to correct all your homework because I did post the answers on my website. So please check your answers also. Next week, one of the Zoom meetings that we have will be for questions. So before you turn it in, you could ask questions on how, like, because I know some of the problems are difficult, but yeah. And then I'm going to figure out how we're going to do possibly a test because we still have to test chapter 9 and I don't want you guys to forget everything. So we'll figure that out. Okay, so this is a learning process. We're all trying to figure this out together. So just be patient and thanks for being flexible, you guys. Okay, have a good weekend. I'll see you later. Bye.